Video will cover the first part of our notes on particle motion. Particle motion is a topic closely related to physics. Many times we'll refer to a particle's position, velocity, and speed and/or acceleration. We can say particle, but it can just as well be a car, a bicycle, or anything that has a straight line motion to it. We're going to take a look at the relationship between position, velocity, speed, and acceleration of things that are in motion. We'll also be able to determine when objects are stopped, moving left or right, up and down, and speeding up and slowing down. Motion problems are among the most common types of free response questions on the AP exam. Position is referred to as x of t or s of t. Velocity is referred to as v of t and is equal to the first derivative of position. It is a vector, which means it has magnitude and direction associated with it. Acceleration is referred to as a of t and is equal to the derivative velocity or the second derivative of position. Speed is the absolute value of velocity. This only has magnitude. It does not have direction associated with it. Notice that all of these are a function of time, t. The antiderivative, and it says if you know the derivative, then you can reverse the derivative process to find the original function. The original function will be referred to as the antiderivative, and the process of doing this is called antidifferentiation. We're going to save this for Unit 4, but just, a glimpse into the future. Okay, so initial means when time is equal to 0. At the origin means when position is equal to 0. Or we can say x of t is equal to 0. At rest means velocity is equal to 0, or v of t is equal to 0. If the velocity of the particle is positive, then the particle is moving to the right. If the velocity of the particle is negative, then the particle is moving to the left. To find the average velocity over a time interval, we're going to divide the change in position by the change in time. So the change in position divided by the change in time. The instantaneous velocity is the velocity at a single moment in an instant, and it's found by evaluating the derivative at a time. And that's the derivative of position. Or we can say v of t, which is equal to x prime of t. If the acceleration of the particle is positive, then the velocity is increasing. If the acceleration of the particle is negative, then the velocity is decreasing. In order for a particle to change directions, the derivative of position must change signs. So we can say that y prime, let me say instead of y prime, x prime of t is equal to 0. And you know what? I need to correct that. It actually does have to change signs. So I'm going to say that, back this all up, the derivative must change signs. So x prime of t must change signs. If, for example, and let me just clarify this, if your velocity is equal to 0, in this case, you're still moving to the right. But if your velocity does something like this, you're moving to the right while your velocity is positive, and then you're moving to the left when your velocity is negative. So it has to not just equal 0, but it must change signs from positive to negative or negative to positive. One way to determine total distance traveled over an interval is to find the sum of the absolute values of the differences in position between all resting points. So let's take a look at an example. If the position of the particle is given by this, x of t is 1/3 t cubed minus t squared minus 3t plus 4. Find the total distance traveled on this interval. So we want to find the total distance traveled, not just displacement. So all the distance left plus all the distance right. It's the sum of the absolute values of the distances between resting points. So we need to find out, well, when is this particle at rest? The particle is at rest when the velocity is equal to 0. So we have the position function. So we need to find the derivative. We need to find the velocity. So x prime of t, or v of t, would be, well, let's see, if I find the derivative, I'll just use the power rule here. So that's going to be t squared minus 2t minus 3. And we want this to equal 0 because that's when our particle will be at rest. If I factor this, x minus 3, x plus 1, I'm going to have, sorry, I always do this. These need to be t's. So I'm just going to present, let's see if I'll go ahead and change this because we're talking about time. All right, so at a time of 3 or at a time of -1, this particle's at rest. Well, we're only looking at the interval between 0 and 6. So -1 is over here, and I don't care about that. I need to find out what's going on between 0 and 3, and then from 3 to 6. We know we're at rest right here. All right, so if I plug in a value, something between 0 and 3, like 1, into my velocity function. All right, so what I'm going to do is I'm going to look at these. If I plug in a 1 to this first factor, that's going to be a negative. This will be a positive, but the product of the two is going to be negative. So I know that I'm moving left. All right, so now let's plug in a number between 3 and 6, like 4. All right, so if I plug in 4, again, this is going to be a positive, and this is going to be a positive, and the product of two positives is positive. So this is positive. I'm moving right. So my particle is moving left from time of 0 to a time of 3, and then we're stopping, and then we're moving to the right from a time of 3 to 6. So now I need to find the total distance, though, and that's position. So now I need to say, okay, well, what is the position at a time of 0? If I plug in 0 to my function here, I'm going to get 4. So I know I'm starting at a position of 4. At a position of 3, let's see, where am I? If I plug in 3 into my function, let's see, 1/3 times 3 cubed minus 3 squared minus 3 times 3 plus 4. And let's see if I have that answer written down. 3 cubed is 27. That's a third of that is 9. Minus 9 is 0. Minus 9 plus 4. Hey, how about -5? So I know at a time of 3, I'm at -5. So between 0 and 3, I've moved from 4 to -5. That's 9 units. 4 minus -5. And it's the absolute value because it's the distance. That's 9 units. All right, so now let's figure out, where am I at 6? 1/3, 6 cubed minus 6 squared. 3 times 6 plus 4. And I've already worked this one out. These are some bigger numbers, so I'm not even going to try that without a calculator. I believe this is 22. So from, let's see, -5 to 22, that's 27, for a total distance of 36 units. In calculus, units, you have to put them. If they're not given, then you write down units. Okay, so total distance traveled, that is the sum of the absolute values of the distance between resting points. So I'm going to just write that down. That is the sum of the absolute value of distances between resting points. and resting is when your velocity is equal to 0. So not too bad. Let's try another example. Okay, so in this example, we're going to actually have 6 questions that go with this function. So get some paper and let's start working. It says we have a particle that's moving along a line, so that's position at any time is given by this function. This is our position function, where x is measured in meters and t is measured in seconds. All right, so find the displacement of the particle during the first 2 seconds. Now, displacement is different than total distance. This is just from 0 to 2, how far have you moved? All right, so let's go ahead and get this one started. So, x of 0, if I plug in 0, that's 3. X of, and this is part A, x of 2, 2 squared minus 4 times 2 plus 3. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. And so I can see that I've gone 4 units. Starting at 3, moving to negative 1, that's 4 units. So 3 minus negative 1, 4 units. Actually, I think we have 4 meters. This is the displacement of the particle within the first 2 seconds. Okay, part B. It says find the average velocity of the particle during the first 4 seconds. Okay, so average velocity is the change in position, x of t. I don't think I'm going to put it in parentheses, change in position over the change in time. So we want to find how far we've moved. We want to find the average velocity during the first 4 seconds. So let's see, change position. So I've got to figure out what is x of 4. And x of 0 minus x of 4, 0 minus 4. I'm going to erase that and start over. X of 4 minus x of 0, 4 minus 0. It shouldn't make a difference as long as you're following the same order. So let's see, x of 4, I don't know what that is. Let's calculate it. Okay, so that's going to give me 4 squared minus 4 times 4 plus 3. 16 minus 16. Okay, so that's 3. Nice. So this is 3 minus x of 0. We know that's 3. 4 minus. Okay, so this is just 0. So the average velocity is 0 meters per second. Okay, part C. Find the instantaneous velocity. Okay, instantaneous velocity, that's the derivative of velocity. And so, derivative of position. So x prime of t, or v of t, at 4 seconds. Well, let's see. Using the power rule, I get 2t minus 4. And v of 4 is equal to 2 times 4 minus 4. 8 minus 4 is 4. And let's see. This is in meters per second. Velocity is meters per second. Okay. Just checking my notes, make sure I covered everything. Yes, let's try the next page. Next questions. Same function. Find the acceleration of the particle when t is 4. Okay, so acceleration is the derivative of velocity. So let's see, a of t, which equals v prime of t, which is also the second derivative of position. So let's see, we know that v of t is, I'm going to go ahead and write it over here, 2t minus 4. The derivative of velocity is just going to give us 2. So the acceleration is constant. Is a constant 2 meters per second squared. Okay, so this is the second derivative. The derivative of velocity is meters per second. The derivative of that is going to be per second. And so then the resulting units is meters per second squared. All right, so that's part D. Sorry, I didn't label that. All right, next. E. Describe the motion of the particle when t is between 0 and 4. At what values of the particle, what values of time does the particle change direction? Okay, for this, I make a chart. I'm going to have time. We're starting with time of, and I'll just put 0 right here. Time of 0. And then, well, do we know when our particle's at rest? Our particle's at rest when velocity is equal to 0. So 2t minus 4 equals 0. Add 4, divide by 2. So at a time of 2, we know the velocity, v of t, is going to be 0. Okay? And let's see, we're going between 0 and 4. So let's see, what's going on at a time of 4? I don't know. Let's see. What is this particle doing? Here's our first stop. Let's put on this chart position, and our position at a time of 0. Well, at a position at a time of 0, we're at 3. If I evaluate the position function, where am I? I am at 3. So this is going to be 3. This is where I am. And then we know at a time of, let's see, I have to flip back to my other page. Didn't we have, yeah, what is position at 0 and 2 seconds? At a time of 2, we are at a position of -1, and I think that was the only thing I knew. Okay, that's all I knew. Let's find out what is the position at a time of 4. So, oh wait, we already know that, right? Position, no, we're at 3 again. If I were to plug in 4 into my position function, that would be 16 minus 16 plus 3. Okay, so we're starting at a position of 3 at a time of 0. We're at -1, so we know we're moving left. If I were to plug in, and this is, I'm just testing a value here. So I'm testing 1 in this interval between 0 and 2. If I take 1 into my velocity, do you see how I'm going to have a negative value, v of 1? That's going to be negative. So I know I'm moving left. So my velocity is negative. I'm moving left. This is left. And that makes sense because if we're starting at 3 and then we move to -1, we have got to be moving left. Okay, so now let's test a value over here. So let's test 3 into our velocity function. So that's going to give you 6 minus 4. That's positive. So we know that this particle is moving to the right. And, well, that makes sense because we're at an ending position at 3. Okay, so let's see, do we need to have anything else? We know we're stopped at a time of 2 because that's where our velocity is equal to 0. And I think that's enough that we can go ahead and start with a description. And for the AP test, you need to just write it out. So here's my description. The particle starts at x equals 3, then moves left, and we know this because the velocity is negative for 2 seconds. And you can write this better grammatically if you want, or whatever. Then comes to a stop. And we know that because our velocity is equal to 0. V of 2 equals 0. The velocity at 2 is equal to 0. Okay, so, and that is at a position of -1. Okay, so then the particle changes directions. And we know that because right here we're changing from left to right at 0. Particle changes directions and moves right for 2 seconds and stops. And well, I don't know if it stops, but because I'm only looking at this interval, and is at a position x equals 3 at t is equal to 4 seconds. Okay, so I think the particle starts at 3. That's the position at a time of 0. Then we move to the left because the velocity is less than 0 for 2 seconds. Then we come to a stop because the velocity is equal to 0, and we're at a position of -1. Then the particle changes direction and moves to the right for 2 seconds. I should probably go ahead and add in because velocity is greater than 0. That's why we know it's going to the right. It moves right for 2 seconds and is at a position of x equals 3 at a time of 4 seconds. Folks, you are going to need to write detailed explanations. This is one of the most common free response questions, and it's going to have A through F, if or more. Okay, last question. It says, when is the particle speeding up and slowing down? Okay, so the particle speeds up when velocity and acceleration have the same sign. Slowing down when velocity and acceleration have opposite signs. So we need to find acceleration. Okay, so back to our A of t. Let's see, I'm going to do A of t. Well, the derivative of velocity, which is acceleration, would just be 2. So back over here to my my timeline here. Let's see, I'm going to add on A of t, and for the whole thing is a positive 2. So velocity is negative when acceleration is positive between 0 and 2. So my particle is slowing down. Velocity is positive and acceleration is positive between 0 and 4. I'm sorry, between 2 and 4. So my particle is speeding up. All right, so I'm going to write that down. So I'm going to go ahead and erase this stuff over here and write my explanation for my particle speeding up or slowing down. So we know that the particle is slowing down between time 0 and 2, or you know what, I should probably just say from t equals 0 to t equal 2. Because you have to justify, because velocity is less than 0 and acceleration is greater than 0. They have opposite signs. Particle is speeding up from t is equal to 2 to t is equal to 4 because V of t and A of t are both positive, greater than 0. Okay, let's see. I think we're going to stop right there for part 1, and we'll pick up with this problem for part 2.